will deliver the lecture of the foundation engineering and the ground improvement for the piling. So my name is Ray, working in Department of Civil Engineering as a postdoctoral researcher. So I'm very glad to deliver this lecture. So firstly, I will introduce the contents of this lecture. There are 5 parts in this lecture. The first one is just to introduce the objectives of the lecture. And then I will introduce the design of piling according to the Eurocode. There are different testing methods for the design. The third part is to introduce the resistance of the inner-bearing piles, and then to introduce the piling of the embankments. For the piling of the embankments, we mainly focus on the pile raft structure, the pile head structure, and the arching principles. Finally, we will talk about the beddings for piling and excavation near the piles. So let's start. So after the lecture, I hope you could achieve these learning outcomes. The first one, I hope you can design a simple pile structure based on the Eurocode. And then I hope you can know the design principles for the end-bearing piles. Also, you should know the slides between the pile raft and pile head structures, know the arching principles. Finally, I hope you could recognize the risks related to the bedding for the piling and the excavation near the piles. So now let's start with the piling design. So as we know, a stable structure should always start with a good foundation. So the pile foundation is a good choice for in the construction. So look at this picture. The pile is a long, strong column, which is made of different materials such as the wood, the concrete, and the steel, which is pushed into the ground. A good example for the pile foundation is the city of Venice, which is very famous for being built on the wooden piles just over the seawater. So now we have a question: why we choose the pile foundation instead of others? So normally there are 2 different situations for choosing the pile foundations. The first one is when we have the weak soil near the surface and it cannot support the weight of the building. So if we choose the pile foundation, the load of the building can bypass the weak layer and transfer to the strong soil layer below it. The second situation is if we have the building structure has a very heavy concentrated loads, such as the high-rise building or the water tank or bridge. At that time, we just choose the pile foundation. So here's a video to introduce how the pile preparations. So this is the equipment for piling.
This is called as pile rig. This piling machine, and this is a concrete pile which is inbuilt installed. So first the piling rig takes the pile and sets it into this rig, and then it goes to this place where the piling is done. So this is the preparation of the piling. And maybe you can add this one. There is probably nothing else.
So this is the driving process of pile. You can see the machine just push the pile into the ground.
One thing which I just comment this one. So this driving of this pile. So you know that in Finland we have very soft soil clays, and when this driving is done, so typically through this very soft glaze, So even though we are speaking that we are driving the pile, but typically, I think it can be seen in the beginning of this video, so that they practically push the pile through this very soft layer. I will tell you soon why this is done. Only after the resistance of the soil comes bigger, so then they start driving. So there is this soft layers are penetrated with pushing, and then after that one there is this driving.
Yes.
Okay.
So now we just introduced several common types of the piles. The first one is the end-bearing piles, and it's often used in Finland instead of other piles. So for the end-bearing piles, we can say the bottom end of the pile just rests on the intersection of the weak and strong layers, and the load of the building can bypass the load to the weak layer and transfer to the strong layer. And another common type of the pile is the friction pile. So the friction pile is work on different principles. The pile just transfers the load to the soil directly and across the full surface of the pile by friction. So to visualize it, we can imagine that we try to push a metal cylinder into the top of the frozen ice cream directly. And the frozen ice cream has a strong friction properties to support this cylinder. The greater the depths are, the ice cream can support more load. So this is similar to how the friction pile works. So now we have questions. So let's join in by scanning the code here. So which of the following is a disadvantage of the pile foundations? Oh, no, sorry. Okay, so now let's talk about the answers. So the first one is unable to support the heavy loads. Of course, it's wrong. It can, of course, obviously it can support the heavy loads. And it's needed installation, so it's very expensive. Yes, that's correct. It's one of the disadvantage of the pile foundation. And the installation of the pile may impact the environment, especially for the noise pollution. Yes, that's correct, as the video shows. So number 2 and number 3 are the disadvantage of the pile foundation. So for the design methods of the geotechnical bearing capacity of the piles, according to the Eurocode, generally we use 4 different methods. The first one is the static loads test. If we have the results for this, the calculations and the empirical knowledge can support the design. Here I should highlight that when we do the loads testing, the test seldomly stopped until the failure of the pile. It's very different from the dynamic one. So the second is the dynamic load testing results. This is very often used in Finland for the design of the end-bearing piles. And both the static load test and dynamic load test are the common methods for the design. Another method is the empirical or analytic calculation methods, which the accuracy has been verified by the static or dynamic load tests in the similar environment. In Finland, the calculation methods are always based on the equations, and we should use some different ground investigations to help design. So sometimes it can accepted for this method without the load testing. The last one is observe the behavior of similar power foundation. So if we have some design projects for the piles, and which is similar to the previous cases, we can use the result of the ground investigations and other tests to support our design procedure. Another thing to remember is the load test can be done for the already installed trial piles or the operational piles, but it's a part of the foundation. Okay, now to design the pile, we should know how the pile will feel. So there are different feel mechanisms for the piles. Shown in this picture. From figure A to C, the failure is caused by the compression, and especially the B is the structural failure of the pile, and the figure C is the backing of the pile. And the figure D and E are caused by the tension. Figure H is caused by the horizontal or transverse loading. So this is kind of bending, and this kind of shearing. So sometimes there will be some combined mechanisms for the failure of the piles. This picture shows some good example for the some parameters used in the static load testing. So this is the design resistance based on the standard, and this is the testing result. If we take a lot of tests and then take for example, the average results of the testing results, maybe it's closer to this one. And the Q limit is the limit resistance, which is the upper bound of the design resistance we used. So in the Eurocode, the determination of the resistance is based on the geology of the Central Europe. In the Central Europe, the bedrock or the strong soil layer is often very, very deep. So in order to save money, the friction pile is more common compared to the cases in Finland. This is different situation. So the Eurocode is not perfect, especially applied to the condition in Finland. And in Central Europe, the end-bearing pile is not often used, but in Finland and Sweden, it's very common. So in the Central Europe, the soil layers are thick, and the clear bearing stiff layer or the bedrock at the great depths. So the end bearing pile is more expensive. Based on this, Eurocode emphasized the static load test as a reference. But in Finland, because we often use the end bearing pile, so we prefer the dynamic load test as a reference for the design. In Finland, the dynamic load tests are reliable enough for the design of the end-bearing pile, and additional static load tests are not needed. According to the Eurocode 1997, the dynamic load test can be used to assess the compressive resistance of the pile when we have enough ground investigations, and the method has been calibrated using the static load testing in a similar environment. So there are some notes on the analytical methods. The first one is the bearing capacity changes during the installation as soil conditions change. So that's, we can imagine that if we push the pile into the soil will be denser during this process. So that's why the bearing capacity will change during this isolation process. Also, this depends on different isolation methods. Secondly, the tip resistance and the shaft resistance depend on each other because we do the separate calculations. So it may lead to the inaccurate result. Finally, the analytic methods usually lead to the conservative results because it's based on the equations instead of the real geological conditions and testing. So the analytic method should not be used alone here, and it should, we can also use some testing load testing to help design. Generally, when we get the constitutive results in the geotechnical design, it doesn't matter, we can accept it. But if it's not conservative results, we should be careful. Maybe we should put another safety factor for the design. So that's all. That's a brief introduction for the Eurocode design. Now let's invite Professor Lina for give us very specific details for how to design the Eurocode according to Eurocode.
Okay, thank you for the introduction. I have my own so let's just take this one away. Okay. Now you got big repetition. Sorry that this one is. Yes. Okay, so hi everybody. I promised that I won't be here anymore, but now I'm back again. So we will speak about this. I hope that my voice will stay because I got a flu. Okay, so I will go one step backwards. I'm sure this one, let's go backwards. So I don't know why it doesn't show this one. Okay, but let's try this one again. Yes, okay, so I will go back to this one because I want you to say that today my part will concentrate on this dynamic load part, but I can stay about this empirical. So when we have planned that we have a building where we want to use piling, so we need to define how many piles we need. So we need to do some kind of preliminary design, which has been done by using this empirical method. I think Anos last time told you how this you can do, so that you define practically either the bearing capacity of the pile using this end bearing definition, or if you have frictional piles, so then you can define the tip and shaft resistance of the pile. But like I said, I will go back to this one. One thing I want to say about this one, maybe not this slide, but you have to remember the pile capacity depends on the piling. So what's the behavior of the pile capacity in the end depends how it has been installed, how successful the installation has been. So it's not only the structural capacity of the pile, but you have to understand that this geotechnical capacity of the pile comes from also from the